Bismillahirrahmanirrahim. We're starting June 2020 paper 4.2. First question, it says, a tram starts from rest and moves with the uniform acceleration, okay? With the uniform acceleration. So we need to underline this thing. So with uniform acceleration for 20 seconds, the tram then travels at a constant speed v for 170 seconds before being brought to rest with a uniform deceleration of magnitude twice that of acceleration. The total distance traveled by the tram is, this is the total distance. Sketch a velocity time graph for the motion stating the total time for which the tram is moving. Okay, so guys, you see, this would be something like this. Um, Try to have a decent scale here, like, you know, these are the maybe first 20 seconds here, and it accelerates uniformly up to a speed of v. Okay, so that means there has to be a straight line joining these 2 points here. Okay, so let me use this line option here so that I can draw this accurately. Okay, and then it says it continues with this constant speed for the next 170 seconds. So 20 plus 170 is going to be 190, okay? And then, so this is going to go up to this for the next 170 seconds. And then it says with the uniform deceleration of magnitude twice that of the acceleration. Suppose if the magnitude of acceleration and the deceleration were same, so the velocity it gained in 20 seconds would be the same velocity lost in another 20 seconds. So since the deceleration is twice, so it would mean that half the time would be taken for this process, okay? So this means if you join this with this, so this would be a steeper line over here, okay? And here is the time 200 seconds. So you must label this completely. This is the time in seconds, and this is the velocity in meters per seconds. Okay? Okay, let's go on to the next question. Now, the total distance covered is, let me note it down here, that is 2,775 meters. Let's keep that in meters because we have velocity in meters per second and time is in seconds. So this distance has to be converted into the meters as well. Now it says find V. Okay, so you have the area of all this shape here. That is a trapezium. So let's use the formula for the area of the trapezium to find this V here. Okay, so that is going to be like, you know, all this length is 200 and this length is 170 over here. So we have half into sum of the parallel sides, that is 200 plus 170 times the height, that is equal to the total area. Okay, and if you solve this for me, what is this? 15. Thank you, Bacha. This is 15 meters per second. Now it says find the magnitude of the acceleration. So you can simply find the gradient, or you can use that formula V equal to U plus AT as well. Okay, V equal to U plus AT, or you can simply use the gradient as well. So the final speed is 15. The initial speed is 0. Acceleration has to be calculated. Time taken is 20. So this acceleration, I think that is 3/4 meters per second square. Just to confirm the answers here, let's see what are the answers. So we have, yeah, V is 15 and the acceleration is 0.75. So we are perfectly all right here. So let's clear all of this and move on to the second question. So please try this first of all, okay? And then I'll be doing that, inshallah. Okay, this question is on resolving forces and forces in 2 dimension maybe, and then basically you people need to be very good at resolving forces for this. Okay, so now we are given that there are 4 coplanar forces with all these magnitudes and acting at these given angles, Now, this is the key word over here that you have to pick, that all these forces, they are in equilibrium, okay? So that means if you find the Rx, that will be equal to 0. If you find Ry, that will be equal to 0. And clearly you will have two equations. You will solve them simultaneously and then you will be able to get to the required values of P and theta. Okay, so I'm going to resolve this force of this 3P Newton in this way. Okay, if this is 30, so this is going to be 30 degrees here. So this one is 3P sine 30, and this one is going to be 3P cos 30. Then I'll be resolving this force this way, maybe like this, just to avoid any overlapping here. You can go for that overlapping if you people are not confused. You know that what has been drawn when where. Okay, now this is going to be, no, this is going to clearly confuse me. I would show it here. So this is P sine 30, and this one is P cos 30. And then I'll be resolving this force this way. Okay, so this is going to be 20 cos theta, and this one is going to be 20 sine theta. Okay, sorry, theta. Why did I write 30 here? Okay, so now Rx. So Rx, I'm going to keep this my basic direction for the Rx. So that is going to be 20 cos theta. There is one rightward horizontal force, है ना? Then you have minus, there is 3p cos 30, that is under root 3 over 2, okay? And then you have p cos 30, that is also under root 3 over 2. So we have just three horizontal forces, yes? So that is equal to 0. So this 20 cos theta is going to be equal to 4 under root 3, and there is going to be 2 under root 3, है ना? This is 2 under root 3p. That is my first equation. Okay, from here we have, I'll be keeping this upward as my basic direction here. So I have 4p, then I have 3p sine 30. So you know that sine 30 is half. So this is 3p by 2. And then minus the downward forces. I have this p sine 30. So that is half p. Okay. And then I have this 20 sine theta. And that is equal to 0. So guys, we have 4p, 3 over 2p minus half p. So that gives me p. So that is going to be 5p, and that is equal to 20 sine theta. Okay. Now these are very easy kind of equations. You can simply divide both of them side by side. You will be able to get to that theta first of all. Okay. So I have 5p 5p over 2 under root 3p, that is 20 sine theta over 20 cos theta. So you have these p's getting cancelled, these 20s getting cancelled. So you have tan theta equal to 5 over 2 under root 3. And we just need the basic angle. So please tell me, what is this theta? 55.28. And then just to quote it, I'll be writing this correct to 1 decimal place. And when I have to use this again over here, maybe, so this is going to be 20 cos 55.28. That is 2 under root 3p. So what is this p, bacha? 3.29. Thank you, beta. 3.29 newtons. Let me quickly look at the answers here. Okay. So we have 3.29 and 55.3. Okay. So we move to the paper here. And let's go to the next question if there is no problem with the solution. Okay. Mashallah, you people are looking to be confident in your P4, by the way. Okay, here is, oh my God, 8 marks. These are really very, very dangerous questions where you don't have the parts, but collectively you're going to bombarded with an 8 marks question. So please go through this very carefully, underline the given information, and see what do you have to find and what rules, what formulas you will be using here. Okay, now it says a particle of mass 2.5 kg is held in equilibrium. Again, we have the equilibrium situation. So when you have equilibrium, that means uh, the forces which are trying to move it would be equal to the forces which are trying to resist that movement. Okay, so um, now there is a rough plane, so you need to underline this. Okay. Uh, Okay, the coefficient of friction is given, that is 0.3. It says find the greatest and the least possible values of t. So we shall assume that there are going to be two situations, one where this particle is about to move upward, like it is about, so there is a limiting equilibrium here. Okay, and then the second case when this will be about to move downwards. So in any case you need to, I love these resolving forces on such diagrams. First of all, you have to show the weight downwards, that is going to be 25 newtons. Secondly, you need to resolve this weight parallel and perpendicular to this surface over here. Okay, these angles should look like, now let me erase this because this doesn't look like a right angle here. So if you try to maintain a right angle, you will not be confused yourself. You see, like this. So this is going to be this, and this is going to be your R over here. Okay. Whenever you have to deal with the coefficient of friction, you need to show this R. You need to determine the value of R over here. Okay. So now if this is 20 degrees, then we can say that this angle is going to be 20 degrees here. Okay. So you have this as 25 cos 20. This one is 25 sine 20. Okay. And then you will be resolving this t as well. So let's resolve this t. So this would be resolved like this. Okay. So this one is t cos 60, and this one is going to be t sine 60. Okay, now I'm going to assume that this is about to move up the plane. Okay, so first case, when it is about to move, you must mention this in your solution, up the plane. Okay, when it is about to move up the plane. So it means the frictional force would be acting downwards. Let's suppose the frictional force is going to be X newtons. Okay. The good students will be mentioning that what does this X mean here in your solution. So you must mention, okay, this X is the frictional force. Okay. Try to facilitate your examiner so that he facilitates you in return. Okay. So this is the frictional force. Acha. So I need many things here. I first of all need to know what is R. Then I need to know what is this X. One thing that is, I'm quite sure that the upward forces would be equal to the downward forces. ठीक है ना? That is the key, principle, key rule going to govern this solution over here. Okay. So the upward forces, I have just one upward force, that is T cos 60. Okay. That is T cos 60. Let me write it down. That is T cos 60. Up the plane. Okay. T cos 60. And then down the plane, you have the weight, first of all, that is 25 cos 20. 25 cos 20. And then you have the frictional force. Now these are the two forces over here. Okay. So let us determine this x first of all. If you want to determine x, you need to know what is r. So what is your r, bacho?
There isn't a 25 sine 20 down the plane.
Oh, sorry. Thank you, beta. Thank you for this staying alert here. Thank you very much, beta. 25 sine 20. Okay. Yeah, I have written it myself and I've just read this wrong. Okay. Now, what is your R over here? Very good, beta, because your R plus T sine 60, that is equal to 25 cos 20 over here, okay? So your R is going to be 25 cos 20 minus t sine 60. And from here we can find this x. X is equal to mu r. Okay, so this is going to be 0.3 into this. Don't use your calculators right now. Okay, 25 cos 20 minus t sine 60. Okay, if you started using calculators at this stage, you will be doing many rounding offs here, okay, and you will go away from the actual answer. So here we are. Now we have just one unknown here, that is going to be t. So this is going to be like this t cos 60, that is going to be 25 sine 20 plus 0.3 times 25 is going to be 7.5. Yes, 7.5 cos 20. And then you have minus 0.3 t sine 60. Guys, please don't use the calculators. Please be patient over here, okay? So I'll move this term to the left hand side, okay? And I'll be skipping some steps here. When I move to this side, I'll be taking t common from here. So this is going to be cos 60 plus 0.3 sine 60, and that is equal to 25 sine 20 plus 7.5 cos 20. Now you go to your calculator. In the fraction mode, in the numerator you write this 25, and do check the mode of your calculator. In your mechanics paper, this should always be mostly be in degrees mode, okay? So write all of this in your denominator, and with one, you know, press, you will be getting the answer, the exact answer. So what is that? 40? So that is 40.8 newtons. Okay? Is that right? Please check, all of you. It is 20.5. Okay, so I don't know who one is telling me correct answer. It is 20. Let me check from the. It is 20.5. Majority saying 20.5 newtons. Okay, so let me see from here. Yeah, this is right. 20.5 is the right answer. Okay, guys. Now you have to tackle the downward situation. Okay. So first of all, you would say, okay, you will have a new heading about to move down. Okay, I'm just going to make some amendments here. Down the plane. Okay. Now, please see, will your frictional force change? Mhm. Will the frictional force change? Hmm? The direction will change. Will R change? No. Okay, so that means we can use all this working here. Okay, only this direction would be reverted. This will be going towards this side. Okay, so when we say, okay, upward is going to be equal to downward, so this x will be going towards here. Okay, so this is x plus all of this. Okay, and your x is this. So so I have to write all of this. Should I change the signs here? So this would be minus and this would be plus, है ना? And then this would be minus here, and this is also minus, है ना? And please, from your calculators, this is going to be minus here, and this is also going to be minus here. So tell me, what is your answer? 6.26. Are you sure? 6.26. Okay, so that's the correct answer, by the way. So that is 6.26. Okay, so surely this is the minimum force, and that 20.5 was the maximum force. And make sure you do all this working again. Don't start like overwriting there. Okay, na? So you have to give a new, I told you that you have to give a new heading about to move down the plane, and then you will do all that changes. Okay? So here is the fourth question. Try it, and then I'll solve it.